a new project. This is our new project, dual LED flasher, using only one transistor and two resistors. Dual LED flasher. And we have this 6-volt supply battery for our circuit, composed of AAA rechargeable, AAA, for AAA 1.5 each volt, so it is 6 volts in total. And this is the supply, 6 volts to our circuit. Let us supply the voltage, supplying the circuit with 6 volts. Kill the light. Okay, minus the light again. So you can see here, dual LED flasher. When the left LED is on, the right is off. When this is on, this is off. And when this is on, this is off. This is off, this is on. So they are there is an alternate blinking of the LED with the use of 6 volts. And using one transistor, only one transistor. So how did this happen, or what make this LED to become a dual LED flasher? Because of these two LED. This is, let us test the LED. Power voltage of around 2 volts, 2.5. Around 3 volts. So you can see here, it is self-oscillating type LED. Okay? There is no circuit that makes this LED to blink. So this is self-blinker. Or known as blue blinker. And the other one, negative to negative. The positive is the LED with this long leg. Positive. Short leg, negative. So our circuit is composed of two blue blinker. there is no circuit that is making this LED to blink, or any circuit responsible for this blinking. So this is self-oscillating LED. So with the use of the circuit, it alternates the blinking, and it becomes a dual LED flasher using 2 blue blinker and 1 transistor and 2 resistors. This is now the circuit. Figure 1 dual LED flasher using 1 transistor and 2 blue blinker, self-oscillating, or with the oscillator inside this LED, each LED. So we're using 1 transistor, BC547 NPN type transistor. Collector base emitter Q1 is the transistor, and then emitter grounded, base connected is the blue blinker, and then 47 ohms resistor to the ground. Collector connected is the 220 ohms through 6 volts and blue blinker to the ground. So what is the supply? 6 volts, that is the exact supply. What if we're not using 6 volts? How about other supply voltage? What will happen? We're not using the 6 volts battery. Instead, we're going to use the adjustable, supplying the voltage with 3 volts. 3 volts. Still okay. The blinking, but irregular. It is not as good as 6 volts. How about 5 volts? Something wrong with the circuit. 3 volts. So you can see it's blinking very fast. For the 5 volts, 4 volts. 4 volts is okay, but very fast. 5 volts still good. So we can also use 5 volts, but with the fast blinking pattern. And then with the 6 volts, and the best voltage supply is this 6 volts. So in 6 volts, it has a nice blinking properties or blinking pattern compared to the 5 volts and 3 volts. So 6 volts is ideal voltage supply to use, but you can also use 5 volts. We can also use 5 volts, but ideal voltage supply is 6 volts. So that's why we are using 6 volts to achieve a nice blinker or dual flasher. So let us examine why is it that we achieve this dual flasher. Initial state of the circuit, current flows here, and then to the LED. This is now on. Also the current flows here. According to the Kirchhoff's current law, current entering is equal to the current leaving. The sum of the current entering is equal to the current sum of the current leaving. Entering is equal to leaving. So there's a current flows here also to the R2, and this is on, this blue blinker. Now the current also flows to the R1, also to the base of this transistor. Another current division from blue blinker to R1 and then to the base of this transistor. So what will happen to the transistor? It will switch on because there is a current that flows here. If this is on, the current that flows into the output side of the transistor will flow into the R2 and then to the collector to emitter. So this transistor now act as a switch, a short switch, shorting the collector to emitter to then to the ground. Close switch. So this blue LED is off. When this is on, this is off because the current flows into the base switching this transistor, and because of that current flows here, switching the collector to emitter then to the ground, bypassing this blue blinker. Now, the moment that this blue blinker is off, since this is self-oscillating PWM type LED, the moment that this is off or low level, there is no current that flows into the base of the transistor. Therefore, this transistor is open. If this is off, current flows here. Again, to the R2, since there is no base current, current will not flow to the collector to emitter because it is open. There is no base current. So the current flows into the blue blinker, the other blinker. So this is now on. So if this is off, this is on. If this is off, dito, this is now on. So they are alternately flashing, or we call that dual LED flasher. One is on, the other is off. If the other LED is off, the other one is on. Due to the as we have discussed, due to the transistor switching, if this is on and the blue blinker here is on, it will turns off because the current flows directly to the ground. If the transistor is off, the current flows into the LED. So this is now on. Okay? And when this is off, this is on. And this is on, this is off. That is the dual LED flasher using one transistor with two blue blinker LED and two resistors. module, homemade, DIY, with freestyle soldering and PCB layout. Homemade. This is dual LED flasher with 2-pin header. 1-pin header with 2 pins. 2 pins header. And we're using this battery. I'm soldering, or I made a pin header for this battery 6 volts, so that we can use this for as a supply. So let us now check if it still works. So we have now the dual LED flasher.